We have seen that a transistor consisting of three terminals, namely emitter, base, and collector. So, to connect a transistor in a circuit, we need four terminals, two for the input terminals and two for the output terminals. But a transistor has only three terminals. So, the connections of a transistor circuit are established by making one of the terminal common to both input and output. That means we will make either emitter common to both input and output, or we will make base as a common terminal for input and output, or we will make collector as a terminal for common terminal for input and output. So if you consider these two diagrams actually represents the symbols of a NPN transistor and PNP transistors respectively. So now, since the transistor is having only three terminals, to connect a transistor in a circuit we need four terminals, so we will make one of the terminal to be common to both input and output. So depending on this one, we can classify the transistor connections into three categories. One is called common base configuration or common base connection. In this one, the base is common to both input and output of the circuit. Here the emitter is taken to be the input and collector is taken to be the output portions of the transistor. That means emitter in the common base configuration or common base connection, the emitter and base will be the input terminal, and base emitter junction is the input terminal, and collector base junction will be the output terminal in the case of a common base connection. And the second one, if we are making the emitter terminal of a transistor as common terminal to both input and output, then we can have common emitter transistor configuration. In the common emitter transistor configuration, base is the input terminal and collector is the output terminal. That means base emitter will be again the input terminal, and collector emitter will be the output terminals. And the third configuration, here we are making the collector as a common terminal for the input and output, so which is called a common collector configuration. In common collector configuration, we will connect the base as input and emitter as the output. So we will discuss these three in detail in the next. So now let's consider about the common base configuration or common base connection. Thought that the common base connection, base is common to both input and output. Look into this circuit. The first circuit represents the common base configuration for an NPN transistor, and second one represents the common base configuration or common base connection for a PNP transistor. So now let's discuss about any one of these diagram. So here this VEE, the voltage source VEE ensures that base emitter, that is this is the base emitter junction, is forward biased. And the VCB, the voltage source VCB in the output will ensure that the collector base junction is reverse bias. If you look into here, the negative of this VEE is connected to the emitter, so emitter is forward biased, and the positive is connected to the base, so base emitter is forward biased. And the VCB, the negative of this VCB is connected to the base, and positive of this VCB is connected to the collector of this NPN transistor, so the collector base junction is reverse biased. So VEE and VCB ensures that base emitter junction is forward biased and the collector base junction is reverse biased. Now, the two important parameters in any configuration or in any transistor connection is the expression for the current amplification factor, that is, which represent how much current has been amplified to get in the output. So current amplification factor, and the second one is the expression for the collector current. The current amplification factor for common base configuration is represented by alpha. It is defined as the ratio of the output current to the input current. So in the case of a common base configuration, in the case of a common base configuration, the input current is actually the emitter current and the output current is the collector current. So we can, using this definition, the current amplification as the ratio of the output current to the input current. The output current is the collector current and input current is the emitter current. So we can represent alpha is equal to IC divided by IB, IE, the input current. But usually we are using the transistor for amplification purpose, so the signal we are using is an AC signal, so the current will vary, the voltage across the base emitter will vary from particular values in between the signal amplitudes. So the emitter current will also has a variation. In that case, we can define this current amplification factor alpha as the ratio of the change in collector current to the change in emitter current. If delta IC represents the change in collector current and delta IE represents the change in emitter current, then current amplification factor can be written as alpha is equal to delta IC by delta IE, where delta IC is the change in output current and delta IE is the change in input current at constant VCB, the collector base voltage, that is output voltage. So the current amplification factor can also be defined as the ratio of change in output current to the change in input current at constant output voltage. In the case of a common base configuration, the output voltage is VCB and output current is IC and input current is IE. So alpha is equal to delta IC by delta IE at constant VCB represents the current amplification factor. And the value, practically the value of alpha will lie between usually 0.9 to 0.99. And always we know that IE is equal to, we know the expression for the emitter current, IE is equal to IC plus IB. So we can say that from this expression IE is always greater than IC. In ideal cases, if IB is equal to 0, we can take IE is approximately equal to IC, but generally IE is greater than IC. So if IE is greater than IC, then we can say that alpha is always less than 1, or the maximum value of alpha will be 1, and so it is less than 1. And don't misunderstand that the current amplification factor is less than 1 means the common base connection will not do any amplification, but it has remember that the voltages and power will be amplified, or we will have a voltage gain and power gain in the output of a common base connection, even though there is no amplification of the current. Here alpha is greater than 1 means the current is not amplified. Amplification means the output will be greater than the input, but here if you consider the current, the output current is less than the input current. So usually, since the value of alpha is less than 1, we can say that the current amplification is less than 1, but still the voltage will be amplified, or we will have a voltage gain and power gain, since this collector current is appears across the output where we are having a high resistance. So the resistance is very high, so we will in the output, so we will have voltage gain and power gain in the case of a common base connection. Now another important quantity regarding a transistor connection is the expression for the collector current. So now let's see what is the expression for the collector current. So to get the expression for the collector current, we know that this collector current is usually provided by the emitter current, and also since the collector is reverse biased, there is a leakage current flowing through the collector due to the minority carriers. To understand this second part, that is the current due to the minority carriers, let's consider this diagram. Here this one represents a common base configuration with emitter is open, that is emitter is having no current, so IE is equal to 0 in this case. If IE is equal to 0, the emitter is open, then the base collector junction is reverse biased. During the reverse bias of a PN junction, there will be a very small current which flows through the junction, and we call that as a leakage current. So leakage current will flow from collector to the base, the case of a NPN transistor. So in the case of a PNP transistor, we can say that from base to the direction of current will be outside the or away from the collector, but here it is from external circuit to the collector to the base. The other case, it will be from base to collector if it is PNP. So anyway, can say that since base collector junction is reverse bias, there is a leakage current, we can call it as I leakage. So this leakage current, we are representing it as the current which flows through the collector to the base when emitter is open. So we will denote it by IC BO. So it is represented by ICBO. So this is the part of the collector current due to the minority carriers. So the total collector current IC will be the sum of is contribution from the IE and the leakage current I leakage, but the IE, the emitter contribution from the emitter current can be written in terms of the current amplification factor alpha. That is, we know that alpha is equal to I C by IE. So from this equation we can write IE is equal, IC equal to alpha times IE. So using this equation, the contribution from a emitter current to the collector current is alpha times IE. Under the leakage current we are representing by ICBO. So the expression for the collector current can be written as IC is equal to alpha IC equal to alpha IE plus ICBO. So we can also have another expression. Since IE is equal to IC plus IB, we can rewrite this as since IE is equal to IC plus IB, we can substitute it in the above equation, in equation number 1. So IC will be equal to alpha times IC plus IB plus ICBO. So when you take this alpha IC to the LHS, so we will have IC into 1 minus alpha is equal to alpha IB plus ICBO. So this can be written as IC is equal to alpha divided by 1 minus alpha into IB plus ICBO divided by 1 minus alpha. So this one, the equation number 2. Equation 1 and 2 represents the expression for the collector current. Expression for the collector current is the important parameter when a transistor is used for any practical purposes. So we have discussed about the common base configuration or connection of a transistor, where we have obtained the current amplification factor alpha, which is the ratio of the collector current to the emitter current, and the expression for the collector current can be written as either by alpha IC equal to alpha IE plus ICBO, where IE is the emitter current, alpha is the current amplification factor, and ICBO is called the collector base leakage current when emitter is open. And IC is equal to alpha by n minus alpha IB plus 1 by 1 minus alpha into ICBO is the another expression. Now we have to discuss about the characteristics of a transistor in common base connection, that we will discuss in the next lecture.